Okay, welcome everyone and good evening to the presentation of the Artificial Intelligence Master Curriculum. I'm recording my presentation because the university might use it in other places, but once I'm finished, I will stop the recording. So for the questions in the end, you can ask freely. This will not be recorded. So let me maximize the presentation. So all of you, in some sense, have a potential interest in studying the master's curriculum of artificial intelligence. So in today's presentation, I will firstly go through the definition of AI, the fact that it's a very interdisciplinary subject, its impact on society and economy, and some modern applications which are fun and interesting. And in the second part, we will discuss the study program itself, some general information. I will tell you about our distance learning philosophy. We will have a look at the study plan itself and also the qualification profile. And that might be of interest for some of you, the admission criteria. So artificial intelligence refers to the ability of machines to perform cognitive tasks that are commonly associated with human intelligence, including perception, learning, reasoning, planning, speech and language, and also taking actions. And you can see that this is a plethora of fields and very broad. And one old theory thought by Alan Turing to check whether something has consciousness or intelligence is the so-called Turing test. And there, the test goes like this. You have a wall. On one side, you have a human. And on the other side, you have a human that pretends to be a human correctly, and a computer that tries to pretend to be a human. And if humans see beyond the wall, cannot distinguish and cannot say who is the computer and who is the human, then the computer passed the Turing test. So it's sufficiently pretended to be a human. And in many respects, this Turing test can be passed. I mean, of course, we cannot build robots that perfectly look like humans because you go there and watch. But if you only listen to music that has been composed by an AI or by a human, or if you look at paintings here on the bottom right, that have been painted by humans or AI. Or you see a chess game and have to judge who played, did the computer play black or white? In all these respects, computers pass the Turing tests and even have achieved superhuman performance, for instance, in chess. Artificial intelligence is very interdisciplinary itself, and it also relates to many other fields of science. So AI itself is a subdiscipline of computer science. It heavily relies on mathematical subjects. It's connected to sociology, philosophy, psychology because of the theory of mind and the concept of intelligence. And there's the whole field of bioinformatics, which is close to AI. And on the other hand, artificial intelligence itself, as we saw here in its definition, is composed of many subdisciplines, planning, perception, knowledge representation, also the field of robotics, natural language processing. And what we have a heavy focus here in Linz is neural networks and machine learning. All these are subparts of AI. Artificial intelligence dates back already to the 1950s, where Arthur Samuel had two computers play checkers against each other and learn from it. The perceptron was the first artificial neuron concept, so to say. Joseph Weizenbaum's ELIZA was a kind of chatbot. And in the 1980s, one of the subdisciplines of AI, so we just saw there are many subdisciplines, one is machine learning, took really off. Optical character recognition, spam filters, the first Google search, the whole 90s revolution in genomics. This all was based that machines began to learn from previous data. And then about 10 years ago, the so-called deep learning revolution started. So of the modern AI breakthroughs and developments we see in the news every day, are based, can you please mute yourselves? Are based on deep learning. So all the modern image, text, voice, and music, video recognition, or everything that has to do with autonomous driving, or all the recent progresses in playing chess and Go and bridge, or in strategic computer games, these are all based on deep learning. So it's a subdiscipline of machine learning, which itself is a subdiscipline of AI. And the deep learning revolution needed two things, namely fast computers and large data sets. And this is what we had about 10 years ago, and this revolution is still going on. In some sense, you can say that electricity needs some resource, oil or gas or coal or wind or solar, but it needs to come from somewhere. And modern artificial intelligence also needs to come from somewhere. And in the deep learning revolution, this is data, fast computers and data. So therefore, you often read the phrase that data is today's oil and artificial intelligence is the new electricity. But that's, of course, marketing slogans, but there is some analogy and truth behind it. Artificial intelligence pervades commercial applications in an unprecedented manner, and this fundamentally changes how businesses operate across virtually all sectors of industry. So you more or less have to ask the question, where do we not need it? Where are we sure that AI will not play a role and not the other way around? So as we see every day in information technology, when it comes to speech and image recognition or translation, this is all, or your Siri, Google Translate, your Amazon Alexa, this is all machine learning built in. In manufacturing and supply chains, artificial intelligence helps us to optimize production chains and delivery processes. In medicine and healthcare, we also have a focus on that in an elective track. You can make better diagnosis and evaluations using machine learning. And in drug design, it helps you to make prognosis about toxicity or some other characteristic of molecules, and often better than professional humans could do. In education, news, publishing, marketing, and services, we have recommender systems. You see that every day that Amazon or YouTube recommends you what you should watch or buy next. This is all also based on AI algorithms. And also almost in the news every day, I would say, this whole future of self-driving cars and trucks. There is no way you can hard code a self-driving vehicle. There is just too many situations on the road. All companies that try to solve the problem in a hard-coded way, so if then in a normal programming way, they all died out. All the modern developments use neural networks where cars drive on the road, they gather data, and from the data, they try to learn how to behave well, just as we humans do. If you make your driver's license, you have your big natural neural network in your brain and you train it. The impact on economy, this slide is meanwhile a little bit outdated, but it didn't change too much. So the prediction is that in the next 1 or 2 decades, there's a huge impact on whether countries are able to implement artificial intelligence in their industry and economy or not. So in, I would say, standard industrialized European countries like Austria or Germany, you have a base scenario of about 1.5% GDP growth per year if you do nothing and fall behind. And if you keep to be in front of the developments and adopt AI, then the growth rate can be much higher. And of course, this is an exponential law. 1.4 to the power of 20 is much less than 1.03, so 3%. So 1.03 to the power of 20 is much bigger. So there's a kind of an interest effect here. So it is very important for the wealth of nations whether we can be on top of that problem or whether we fall behind. Yeah, as I mentioned, we have a very heavy focus in our master's program on machine learning and perception, in particular on deep learning. You will have deep learning, 2 deep learning courses, 1 LSTM and recurrent network course, 1 deep reinforcement learning course. So the concept of deep neural networks will be of extreme importance. And I, of course, don't have time to explain it now, but the trick is that you have this just mimicking the brain. You have these millions of artificial neurons that are connected to each other by weights. Everything happens in the computer. And then with large data sets, you train. So you input the data, get an output, there's a loss, there's an error, you feed the error back, and slowly and steadily feeding lots of data, the network adapts, all the weights are changed such that it can make good outputs in the end. And once you have, so training such a network, that is the hard part. You need to find the right architecture, you need the data, you need the right training procedure. And for that, you need the experts. You need people like you who study this, who know all these architectures, who know all the details to keep this normalized and so on and so forth. So there's lots of research still happening. And this is not an easy feat and task. Once you have a trained neural network, inference is really fast. You can feed it and get it out of prediction. And therefore, you can do that on the fly. I like it very much. It's for the blind and visually impaired. It was trained on billions of images. It can recognize 5,000 objects. And it can do that in real time on your smartphone. So let's just have, maybe not the full video, but let's watch for a minute. It's really cool. So you walk around and the smartphone tells what you see. So you see, and in fact, I mean, of course, it's not magic in the real sense of magic, but it's close to magic. This was completely impossible 10 years ago. But now we have the data, we have the fast computers, and we have the network architectures for such things. Very interesting, for instance, are also general adversarial networks. There you have two neural networks playing against each other. One network tries to make better and better fakes, so compose music, paint an image, draw a picture, make a photo, and the other one tries to discriminate. It's like Arthur Samuel's two computers playing checkers against each other. So for instance, here, this is also 2 or 3 years old. Here you see photographs of celebrities, and now you can ask yourself which are real and which are not. So what are real photos and what are computer generated? I give you a couple of seconds. You can maybe try to get some candidates. And if you look closely, you indeed will find errors. So here, for instance, the ear is much larger. So from our left side is much larger than the right, and so on and so forth. So in the end, all these pictures are computer generated. None of this is a real person. But these general adversarial networks are really good in faking and creating stuff. And they can also change, you can train them to change zebras to horses, or summer to winters, or photos to pictures, or pictures to photos, or even the style of a photograph into Monet, Van Gogh, and so on. So there is no boundaries. Also very important, and a special course in our master's program is reinforcement learning. It's a very general approach where agents learn in an environment to behave well and maximize the reward. So for instance, you can start with a drone, throw it in the air, and it should stabilize itself. Again, 2 approaches. You try to program that from scratch, extremely tough, or you simply do it again and again. You implement the reinforcement learning algorithm, throw the drone 1,000 times, it will learn itself, like babies. They stumble, and sooner or later they learn how to walk without falling. And in a similar manner, AlphaGo 0 was programmed. So most of you, I guess, have heard of that. Chess was already solved with standard brute force programming back in the 1990s. It's programmed as we are used to be. If that happens, make that. Just try to maximize the position on the board. But this is impossible in Go. Go is too complex a game with too many options. It cannot be solved by a normal computer program. But if you use a deep neural net for the position valuing and a deep reinforcement learning network to play, then in fact, 5 years ago, AlphaGo 0 beat the best human in the world, and since then no human can ever win again. So also this is a field where AI has achieved superhuman performance using deep neural networks. And AlphaGo 0 is even as good. It can start with nothing except the rules, and then it plays against itself. After 3 days, it has grandmaster level, and after 3 weeks, it achieves a performance that humans cannot reach anymore. So it beats the best human, and then it can never be beaten again. The one last thing I want to mention is AlphaFold. It was the holy grail of biology to predict the 3D geometric structure of proteins from the genetic sequence. And for decades, this was a field where crystallographers and others had approaches, but there was only a 40% accuracy in making the prediction. And then deep learning started to be implemented. And then within a period of 4 years, this problem was practically solved, because within almost 90% prediction accuracy, you can predict well how the protein really behaves. You know the structure well enough. So also an extreme success of artificial intelligence. Real AI is, of course, still science fiction. We are still far away from what you know from the movies, because artificial general intelligence, or hypothetical machine that is at least as skillful and flexible as we are, it's even unclear whether we have the right theory or algorithms for that. It's even unclear how to perfectly define this and whether this can exist or not, and whether this is 10 years away or 100 years. So here, nobody knows. But what is interesting to see is this is the peak performance of the best computers in the world. It is a logarithmic scale over the years, so Second World War to now. And this is millions of people and trillions of dollars going from valves to microelectronics to integrated circuits. So this is a feat of mankind, this graph here. It's an exponential graph. And today, for €1,000, you can buy a GPU, which is as good as the best supercomputer at the beginning of the decade. And here, this orange bar here, this is the estimated computing power of the human brain. It's not easy to estimate. There's a huge width here in the estimation. But anyway, so it's likely that computers can reach that. So sooner or later, we will have reached the processing power of the human brain. And then the question is, what is the, so to say, software that we need? But this depends on your philosophy, whether you are afraid of that development or you are very much looking forward to it. Okay, let's go to the second part of this talk, which is the study program itself. At JKU, we started the artificial intelligence program, the bachelor's and the master's, simultaneously in October 2019. So that's 3 years ago, right? So almost 3 years ago, our first master students finished already in summer, and our bachelor students, our first bachelor students, will finish this summer. They now come to the sixth. They are now in their 6th semester. We don't have any access restriction in the sense that there would be a limit of students or some examination. It's not necessary yet. We were among the first modern AI programs in Europe at the time, and the first AI program in Austria. And I think that still we are among very few modern AI programs in Europe. We fully teach in English, so it's really 100% of all the courses, of all the mandatory courses. Of course, you can choose your free electives. You can choose whatever you like in German, but the program itself is in English. It's largely available via distance learning. I will explain that in a minute. We are a technical program, so you will learn lots of math and deep neural nets and specialization subjects and so on. But we have like 10 credits or so in a subject called AI and Society, where you will learn about the sociological and the legal implications of AI. The master's program, which we're interested in today's presentation, is, I would say, in the Bologna system, a standard program. It is 4 semesters, 120 credits. We heavily focus on deep learning, and we have 4 elective tracks, 2 in mechatronics, 1 more in reasoning, knowledge, representation, mathematics. So symbolic AI would be the field, and the 4th track is life sciences. Now a slide about our distance learning philosophy. So, well, Corona fortunately is over for the moment. So we are back on the campus, and our curriculum, as all the other programs at jku, is a curriculum where you can choose physical presence. So all the courses take place in lecture halls, seminar rooms. You can go there, meet with your colleagues. It's just a regular program as all the others here at the university. However, we also have a distance learning philosophy. So if you want, you can basically study without coming to university too much. All course contents of the mandatory courses are available online, lecture notes, slides, very often video recordings in the lecture rooms. After a couple of hours after the lecture really takes place, the video would appear and you can watch it for a couple of weeks. Most courses are even streamed live, so you can sit at home and simply watch or later watch the video. When we have many exercise courses, they either have a fully distance learning group where you simply submit your solutions and they are checked. Some exercises demand presence, but then it's also always an option to choose the virtual presence group. So for instance, I am teaching exercises in summer and 2 groups at jku where people come and go to the blackboard, and my 2 other groups are virtual presence group where we will meet at a certain time in Zoom. People share their screen and show their solutions. Exams are either online or on-site. So there are on-site exams, and then you have to come, and they will take place at jku or in Vienna or in Bregenz. We have 2 distance learning centers in Vienna and Bregenz, so the 2 boundary sites of Austria. And you can also go there and do the written exams there. So the number of required days of physical presence at University of Linz, except the exams, is only about a day per semester or so. If you want, you can largely stay at home. But for the exams, you have to come. And this depends on the semester, how many days these are. Enrollment, it was possible to enroll, I think even also without coming to jku in the Corona times. I don't know whether this is still the case. It could be that you still have to come again to the university to get your ID card. I'm not aware of the current rules now. In Corona, it was a bit different. But what I do know is that you can simply go to the web and find out how the enrollment procedure works. And if you're interested in general admission criteria, visa, and so on, then please email to this address. Okay, I jump over the bachelor's degree. The master's degree is composed as we see it now. So it has this heavy focus on machine learning and perception. We have this AI and society subjects, seminars and practical works. You choose an elective track and some area of specialization subjects, 3 electives, and a big chunk, as it should be, almost a full 4th semester as your master thesis. So let's maybe quickly look at one of the tracks. That would be our robotics and autonomous system track. You see the elective track subjects here: control systems, autonomous system, robotic system, and so on. And the second track would also be in mechatronic. The third would be with mathematics, and the 4th would be in life science. So, but what did not change? What do you always have to study? It's the first 3 lines. The first line is our machine learning and perception subject. So you will learn about computer vision, deep learning, recurrent neural nets, deep reinforcement learning, explainable AI, probabilistic models. So as I said, there's this heavy focus on machine learning and perception. Yeah, and in our AI and society subject, you will learn about the impacts of artificial intelligence to society, about its psychological impacts, about its legal consequences. The qualification profile for the master's program is a thorough education in the modern developments in the field of AI, in particular deep learning. You will require practical training, learn about connections to the legal system, sociological implications, and in your elective track, you get in-depth knowledge either in robotics and autonomous systems, or in embedded intelligence and signal processing, or in the symbolic AI, or in AI and life sciences. We make use of the existing academic excellence and infrastructure at jku. So in particular, our mechatronics colleagues help us in making possible these tracks. And we feel that these tracks are also tailored to the strong local industrial environment. And what is the goal of every good master's program? It's to prepare you for subsequent PhD studies, or of course for the immediate entry into the job market. And that brings me to my final slide, which is the admission criteria. We have three. You can fall into one of three categories. The first category is you have a bachelor's degree in artificial intelligence. This is very rare because there are not many such bachelor degrees. I mean, if you study here at jku, then yes. There are some other programs. So we do not have many people yet that fall into the first category, but there will, of course, be more. But then you simply start, nothing to do. The second category, most people fall into the second category. They have a bachelor's degree in a technical discipline. So that would be some computer science, some physics, some mechatronics, some bioinformatics, maybe some statistics or data science, or some equivalent program at some other university. If you have such a technical degree where we know you learned mathematics, and so calculus and linear algebra, and where we know that you learned programming, it need not really even be Python, because you will learn Python fast if you decently learned C or Java. But if we know that you have covered that, then you will be immediately admitted to the master's program. But within your 120 credits, so within the area of specialization of 3 electives, if you have not also done so, you have to do the supervised techniques of machine learning, unsupervised techniques, and some statistics course. So for instance, all the computer scientists, they don't need to do the statistics course because, or the mathematicians, they only need to do the 6 credits. So we have a very easy way to join in. You simply have to do these courses within the area of specialization subject within the 120 ECTS. So no additional work for you. And then there's the third category. You have a bachelor's degree in a non-technical discipline. Then we will look at your degree. And if we find it possible, we will still admit you, but you will have to do up to 40 additional credit points, usually some mathematics, programming, also the supervised and unsupervised techniques. And people that are admitted in that way have to calculate that they need 6 semesters for the program and not 4, because you will need roughly 2 semesters to come to the level that you can really enter. So to fulfill your 40 credits, so to say, for that you will need a year, and then you study the rest in 2 more years. Okay, that brings me to the end of my presentation. If you have any, if you demand more information, then visit the Master AI site. This is quite a complicated link, so you can simply Google AI jku and get whatever the first hit, and then go there and read our webpage and the program details. We also have an office of the Lit AI Lab there, to which you can write an email. And if you have a very specific question, maybe regarding this talk later on, you can email me. My email address is written here. And with this, I thank you very much for your attention. I will now stop the recording, and I'm available for questions.